Hey everyone, still Tim, still coming to you from Southeast Arizona. Today I would like to talk to you about mitochondria. Why am I making a video about mitochondria? Why am I asking you to watch a video about mitochondria? Well, this weekend, wife and I, we learned a lot about the subject. We saw some doctors, psychologists up on stage. They presented a wealth of knowledge. I took some notes, did my own reading. First comment at the end of all this, I have a bunch of links, just as a jumping off point, so you can do your own reading. Um, that being said, sit down, get comfortable. Video is about 10 minutes long. Please watch it all the way through to the end. There's just a wealth of knowledge, a lot of information I'm going to talk to you about. And please share it. Share this information. Uh, you have a cousin, you have an aunt, uncle, a weird friend from high school that's going to find this to be very informational. And I know this for a fact because I am that weird friend from high school for a lot of people, and I found this information to be interesting, so I'm sharing it again with you. That being said, back in high school, who remembers what mitochondria are? Uh, Friends that did advanced schooling, family did advanced schooling, college biology. How do mitochondria work? What do they do? And what happens when they start to fail and start dying off? This is what I'm going to talk to you about. Two really important things that you should know just to start off with about mitochondria. One, uh, there are studies that are showing that there is a very strong potential for an indirect relationship between the quantity and quality of mitochondria in your body as compared to body fat and cellular inflammation. The more mitochondria you have, the more effective they are, the less body fat you're going to have. The more mitochondria you have, the more effective they are, the less opportunity, the less potential you'll have for cellular inflammation. Cellular inflammation is not an injury where, like, you cut yourself, it's infected, it gets inflamed, or you twist your knee, it gets inflamed. No, cellular inflammation is the initiating cause of just about every chronic disease there is. When our cells become inflamed, it disrupts the hormonal signaling networks in the body, but that's just too much information. That's an entirely different talk. That's like weeks from now when I do a lot more reading, a lot more research. Second important thing you should know about these studies is that it is proven that there is a direct link between the quality and quantity of your mitochondria to your body's energy levels. That's it. More better mitochondria, less body fat, less chance of cellular inflammation, more energy, better energy. How does all this work? Well, at their most basic role, mitochondria are the body's power plants. Mitochondria produce adenosine triphosphate, or ATP. Uh, the mitochondria convert the energy potential of our body's raw fuel sources, be it carbohydrates, be it lipids, or be it protein. It converts all of those into ATP. ATP is refined gasoline, and those are just like the raw fuel sources. Uh, every single cell in your body has thousands of mitochondria. That means your body has the potential to put out a lot of energy. In perspective, like a nuclear power plant, it's not much, but with the natural power we have in our body, we can light light bulbs. That's just the way this energy works. That being said, um, power plants in the real world, they don't run 24 hours a day. They don't run at peak efficiency all the time. They shut down sections here, they reduce this one over here, they do maintenance on the systems. So when a trainload of raw fuel comes to the power plant and it's not running, it takes that raw fuel, sets it aside. And then later in the day, they turn the power plant back on. It's going to be working. A train comes by and it's got a fuel source on it. It's easier for them to unload that train than it is to go over and pull from the reserves. So, just like the power plants, mitochondria, when they are operating, they reach for the easiest process supplies of energy. That's going to be your carbohydrates and your lipids. Well, just like if the power plants are shut off, if the mitochondria is shut off at the time when the fuel source comes in, it just takes that fuel source and sets it aside. In our case, it stores it as fat. Yes, our energy turns to fat if it's not being used at the time. So As the power plants get older, they produce less ATP, and they produce more free radicals. Free radicals, they're bad. They're horrible little things. They're molecules that have only one electron. And as we all know from grammar school, electrons like to run around in even pairs. 2 electrons, 4, 6, 8, 10, 152. They like to be in pairs. So if you have a molecule out there running around with just one electron, it's going to bump into an electron, or correction, a molecule in another cell, and it's going to strip an electron from that molecule. That's going to make that molecule be bad for that cell, and that cell is going to run less efficiently. And when you have one cell in an entire process that is inefficient, it affects the entire process. So let's say free radical gets up on your optic nerve, and it strips an electron from the optic nerve. And it's not just that one. It's going to be hundreds of thousands, millions of free radicals that are bouncing around your body. They strip enough electrons from enough molecules, from enough cells up on that optic nerve, your eyesight fails. And ladies and gentlemen, aging. That's what aging is. The natural process of aging is your mitochondria becoming less efficient, producing more free radicals that are causing damage in your body. That's it. So mitochondria, they recognize this, so they also produce antioxidants. Well, antioxidants are molecules with only one electron. What this thing does is it goes out in the body and it seeks out the free radicals. And once it finds a free radical, it gives it that electron. And next thing you know, that free radical, it's got an even number of electrons, so the cell becomes efficient. It knows what it's supposed to do. So instead of causing the aging process, it does what it's supposed to do. It goes off and does its own job. And that's what antioxidants do. So when you hear about pomegranate juice being rich in antioxidants, grape juices being rich in antioxidants, it's slowing the aging process. I mean, not overnight, but still, that's how that works. This even happens in your brain. As the quantity and quality of mitochondria in your brain reduce, less ATP, less fuel in your brain, which causes the brain decay. Your brain ages, your brain starts to die. Cell by cell by cell. It happens all the time, but again, if we have more efficient and a more number of mitochondria in our cells, it slows down that process. And I'm here to let you know that there are strong theories and published papers linking the health of mitochondria to several brain diseases, to include Alzheimer's and Parkinson's. So, better brain, better mitochondria, more mitochondria, the less risk you are if you have the gene markers for Alzheimer's and Parkinson's. It's just a way of pushing that back or even preventing it. That's what these studies are saying. This means that the more healthy, overall, the more healthy operating mitochondria you have in your body, the more energy you're going to have, the less body fat you're going to have, because your body's breaking down those lipids to feed the mitochondria to convert it into ATP to get us to redo the whole process. And in theory, yes, there are many studies supporting this theory. The more mitochondria operating at peak efficiency there are in your body, the slower the body ages. Yes, I just said that. The more mitochondria you have operating at peak efficiency, the slower the body ages. And that is a slightly more than basic overview of mitochondria. Why do I want to let you know all this? Well, a few years back, a big brain trust came together. They had a lot of money funding them. No political stuff, just a lot of money, a lot of research, people wanting to know. If we could make our mitochondria better, if we could make them more effective, and if we could find a way that they wouldn't turn off, how would our body react? Well, the answer to that is a TED Talk unto itself. Long story short, I know, too late. The answer is PGC1 alpha. PGC1 alpha is a very short acronym for a very long phrase. Look it up. PGC1 alpha. You'll see very long phrase, short acronym. I like it shorter. Best way I can describe PGC1 alpha is that it's the maintainer and operator of your mitochondria. They are the operators and maintainers of the power plant. When the brain sends a signal to turn on the power plant, the PGC1 alpha is activated. They go hit the switch. The mitochondria turns on. It starts converting the raw fuels into ATP, but it's also working on maintaining the mitochondria, making sure it's working okay, making sure it's not dying off. Eventually, as we age, the PGC1 alpha, it becomes less effective. So when the brain tells the mitochondria to turn on, it doesn't, or it only operates at half efficiency. The PGC1 alpha, it's no longer maintaining the cells. So this brain trust, they came up with a little chemical that they called Mito2PQ. It is essentially a better, more experienced power plant operating crew that works with the PGC1 alpha. On its own, our body does not metabolize all the time. It doesn't convert fuel to ATP all the time. It only burns the energy when it needs the energy. That's the reason we can eat a lot today and it'll sustain us for a few days, because it stores the fat, and then the cells burn the fat, fuels the body. By supplementing our diet with Mito2PQ 2 to 3 times a day, we're actually increasing how often the body metabolizes. The Mito2PQ goes into the mitochondria, it works with PGC1 alpha, it turns on that master switch, and instead of leaving it on for about an hour or so, it leaves it on for hours at a time. So it's metabolizing constantly for hours at a time. Do it 2 or 3 times a day, and your body's going to be metabolizing that fat and fueling your body and getting rid of that fat all day, even while you're asleep. And yeah, you're not going to be needing that energy while you're asleep, but your body's going to be using it to rebuild cells. It's going to be using your body, that energy, to repair your muscles. That way, if you lift weights or you're just exercising, those little rips get healed by protein, fueled by the ATP. So that's a really good thing. But you don't even have to be on a keto diet, just a low carb diet. So the Mito2PQ tells the power plants to stay running all the time. If you're on a low carb diet and you bring those fats in, it's just going to be burning those fats and burning the fats in your system already. So you lose weight, you save muscle, and your brain will be better. You're just going to be better. Your body's going to be operating more efficiently. So there you go. Now we know what mitochondria does. We know how they start falling apart. We know the results of what happens when they start falling apart. And now you know how you can supplement your diet to make those mitochondria work better. Because when your brain functions better, you'll have more focus. When your body functions better, you'll feel better. And when your brain and your body are more aligned like that, you're just in a better mood more of the time. It's just the way it works. Better energy, better focus, better mood. And that concludes my talk for the day. If you have any questions or you want to know where you can get the stuff, drop me a message here or send me a message. I'll be sharing this on Heather's page. You can contact her. But seriously, share this with people so they can learn, so they can educate themselves. And have a great day and be the awesome person that you are meant to be.